All right, so here we go with our next section. This is 6.2, and it's second stage into integration. We in the last section in 6.1 we started anti-differentiation and finding the antiderivative. So we started to come up with a process of undoing differentiation, and in the form of a polynomial that ended up being relatively simple. It ended up just being, we're going to increase our exponent by 1. We're going to add 1 to our exponent, and then we were going to divide by that amount as well in each term. We will use that type of differentiation. In 6.2 here, we're going to be looking at polynomials for the most part. And we will do that. A lot of this is hinged around the idea of a plus c on the end when we have these indefinite integrals. When we find an antiderivative, we have to add the plus c on the end because when it's differentiated, the constant goes away to 0. So that unknown we express as c. So in terms of this one, this first one says, so if f of x is equal to 3x squared minus 7, determine capital F when f at -1 is 4. So we need to differentiate this and 3x squared. So remember that our process is, so we will leave our 3 here. We add 1 to our exponent. So this ends up being 3x cubed, but we also have to divide by that 3. When we take the derivative of this, we would multiply 3 by your coefficient and then subtract 1 from it. And so we're multiplying by 3. So to anti-differentiate, we divide by 3 is our step here. The minus 7 is minus 7x when we integrate it, and then let's see, is that piece. Step and just divide this out. 3 over 3, just divide to 1. And so there is that. Our next step would be f at -1 is 4, capital F. -1 is 4, so let's make this 4 is equal to -1 cubed, 7 times -1 plus c. This ends up being 4 is equal to -1 plus 7. Subtract 6 from both sides, and -2 is equal to c. So therefore, we conclude that big F is equal to x cubed minus 7x minus 2. I suppose we should add a little bit of more detail into that. Therefore, at x equals -1, that's the case. We should claim that in here. So at x equals -1, that is our integrated function. And question number 2. It's going to start off kind of similarly. If f of x is this polynomial, determine capital F, and the graph passes through 1, -1. So this behaves very similarly. 4x to the 5, you write your 4, you add 1 to your exponent, and you divide by that. Minus 3, x squared becomes x cubed, we divide by that. Plus 2, we add 1 to 1, and so this is now x squared. We divide that out. Minus 1 as a constant becomes minus 1x. And don't forget plus c. We can just simplify and clean this up a little bit. 2x squared thirds minus x cubed plus x squared minus x plus c. This is going to pass through 1 and -1. And so therefore we end up with 1 is equal to 2 times 6 over 3 minus 1 cubed, 1 squared, minus 1 plus c. We add all this together. This becomes -1 is equal to 2/3 minus 1 plus 1 minus 1. Add 1 to both sides, and we add 2 and subtract 2/3 from both sides. So -2/3 is equal to c. I suppose I didn't need a full extra step for that. That's okay. Therefore, x is equal to 1. Function capital F of x is equal to 2/3 6 minus x cubed plus x squared is x minus 2/3. Oh, cruising right along. We have some motion problems that we're going to look at and revisit. We looked at this stuff earlier in the semester, and earlier in the semester we started off with the fact that we started with displacement, and then when we took the derivative of displacement, that was equal to velocity, and when we took the derivative of velocity, this was equal to acceleration. So that said, the antiderivative of acceleration is velocity, and the antiderivative of velocity is displacement. So that's just going back up the tree compared to what we did before. A couple other things that should be noted: if the object is being thrown upwards, the sign on this, the negative and positive, is going to matter. And displacement, if we're talking about vertical motion, positive displacement is something that's above ground. Positive velocity would mean something that is moving upwards, and negative velocity is something that is moving downwards. That kind of infers then, therefore, acceleration due to gravity is negative because it's pulling down in a negative direction compared to the displacement. So number 3 says an object starting from rest moves in a line with a velocity of vt is equal to 8t minus 2t squared. How far does the object move in the first second? Okay, so this is not a vertical movement. This is just saying that it's moving in a line. And so it makes no discrimination between direction, but we will still have positive and negative directions as it moves backwards and forwards. So if we have Vt is equal to 8t minus 2t squared, if that's what's given to us, then we integrate that to find your displacement. When we do that, this ends up being d of t ends up being 8t squared over 2, and we have minus 2t cubed over 3 plus c. So just to clean this up, displacement at t is 4t squared minus 2/3 t cubed plus c. Now we seem to be a little stuck, and we don't really know what to do from here. We are wanting to find what c is, but if we think about it, at time 0, when time is equal to 0, what is our displacement? And I think it's reasonable to conclude at t is equal to 0, we haven't moved at all. So d is equal to 0. So we have 0 is equal to 4 times 0 squared minus 2/3 0 cubed plus c. C is actually 4, 0. Therefore, d of t is equal to 4t squared minus 2/3 t cubed plus 0. How far does the object move in the first second? So therefore, we are needing d of 1. What's the displacement at 1 second? Ends up being 4 times 1 squared minus 2/3 1 cubed being minus 2/3. Ends up being, what is that, 12/3 minus 2/3 is 10/3 meters. Yeah. All right. And lastly, so here's now a question with vertical movement. Those of you, most of you have probably seen this either in science class or in physics class when you're talking about acceleration, velocity, and displacement and the relationship between those. We're going to kind of build that from scratch with this, and we're going to see how this works. We do know that acceleration due to gravity, a is equal to negative 9.81 meters per second squared. So if a is equal to, and so let's call this a of t is equal to negative 9.81. Therefore, v of t is going to be the antiderivative of that. So negative 9.81 t plus our constant c. Now we do have this initial condition that is told to us. A stone is tossed downward with a velocity of 4 meters per second. So that's at time 0. At t is equal to 0. V at 0 is equal to negative 4. It's negative because it's being thrown downwards. And we have negative 4 is equal to negative 9.81. 0 plus c. C is equal to negative 4. Our velocity function is equal to negative 9.81 t minus 4. Find the antiderivative of that. We integrate this to find our displacement function. And the displacement function is equal to, so we have negative 9.81 is our coefficient. T now becomes t squared, but when we add 1 to our exponent, we're also going to divide that by 2. 4 as a constant. When we integrate that, becomes negative 4t. And again, that is c. But we know our initial condition on displacement as well. We know that at time 0, the displacement, its position, it's 100 meters up. So it's positive because it's up on this bridge. So therefore, 100 is equal to negative 9.81. 0 squared. 2 minus 4 times 0. C, and so C is equal to 100. So therefore, we end up concluding displacement function is negative 9.81 over 2 t squared 4t is 100. So just to kind of look at this, because you've seen this before in science class or in physics class, and this ended up being half of negative 9.81 is your negative 4.95, and or sorry, 4.9, and your coefficient of negative 4 is your initial velocity, and your last constant term, that plus 100, is your starting height. And so that all kind of fits into place, and we've just kind of came up with all of that just based off of 9.81 being acceleration, and explained why. All right, so now we're needing to find how long is it going to take to hit the river. So therefore, it's the water, d is equal to 0. So your displacement, its height, is 0. And so therefore, 0 is equal to negative 9.81 over 2 t squared minus 4t 100. Now, unless you're going to try to factor this, I suppose the next step would be to break out quadratic formula. Negative b plus or minus square root b squared minus 4ac all over 2a. We end up with negative b is now positive 4. Negative 4 squared is 16 minus 4 times negative 9.81 over 2. C, which is 100, all over 2 times a. So when we simplify that, we're going to get two different answers. We'll get a negative one that's extraneous. We're interested in the positive one. We get 4.13 seconds. And that's it for this section. So again, good luck. And if you have any questions, please let me know.